Hello, welcome to our video solution to problem 2 from quiz 4. In this problem, we want to find the area of a triangle whose vertices are given. And our method for finding the area is going to be using the cross product. So let's just quickly recall why the cross product is relevant in this situation. So if I have some point and I draw two vectors away from it, so let's call maybe this vector u and this could be vector v, then we know that u and v are going to span a parallelogram, right? Which I get just by copying u on top and v on the side. And the area of this parallelogram is precisely the magnitude of the cross product of u and v. So the area of this parallelogram is equal to the magnitude of the cross product of u and v. Now, if I cut this parallelogram in half, then I get two triangles which are congruent. And so if I just look at one of these triangles, then I can actually get its area by just taking the area formula for the parallelogram and dividing it by 2. But in fact, this is how I can get any triangle, right? I can take two sides of the triangle and extend it to a parallelogram. I know that the area of the parallelogram will come from the magnitude of the cross product. Cut that number in half, I get the area of a triangle. So all I have to do is take two sides of the triangle and specify the vectors that would produce those sides. So in our case, we have 3 points, right? Let me just quickly label these as A, B, and C. So maybe this could be A, this could be B, and this could be C. And I'm not terribly worried about where they are in 3 space. Right? We know they're going to be in some direction, and I'm not concerned if these aren't actually relatively correct. The point, though, is that if I want to get from A to B, I know I can build a vector, because a vector is just a shift, right? It just tells you how to shift from one point to another. So in this case, to get from A to B, the x-coordinate has to increase by 3. The y-coordinate has to decrease by 1. And the z-coordinate has to increase by 2. I could also try to get from A to C. To get from A to C, my x-coordinate has to increase by 4. Negative 1 up to 3 is 4. The y-coordinate doesn't change at all. And the z-coordinate goes up by 3. So I have two vectors. I have a u, which is equal to 4, 0, 3. I have a v, which is equal to 3, negative 1, 2. And I know that the parallelogram spanned by u and v will be twice the area of the triangle ABC. So the area of triangle ABC is going to equal 1/2 the magnitude of the cross product of u and v. So now all I have to do is compute this cross product and divide it by 2. Well, let's see, I already have these written in vertical form, so it's going to be pretty easy to come up with this cross product. So as in the previous video, which I'll put a link to in the description, I cover up the first column, and now I go 0 times 2 minus 3 times negative 1. So that will be 0 minus negative 3. That will be positive 3. Okay, now to get the middle component, I'm going to cover up that second column, and I'm going to multiply, but now I do it backward. So I go 3 times 3 is 9, minus 4 times 2 is 8. So 9 minus 8 is 1. Okay, now we get the third component by crossing off the third column. And now I go back to doing it in the usual way. So I do 4 times negative 1, which is negative 4, minus 0 times 3. Okay, that's 0. So negative 4 minus 0, which is negative 4. Okay, so I've now found the cross product, and I simply need to take the magnitude and then divide it by 2. All right, well, the magnitude is going to be pretty easy. That'll be the square root of the sum of the squares of the components. So 3 squared plus 1 squared plus negative 4 squared. Okay, this shouldn't be so hard. Let's see, 9 plus 1 is 10, plus 16 is 26. And so the area of this triangle will be root 26 divided by 2.